if you've printed out the worksheet ahead of time, you're kind of following along and you've gotten a few slides in at this point, you might be thinking, oh, usually by slide 3 or by slide 4, we've had a problem. You haven't had a problem yet on the worksheet because a lot of it is we're building into concepts that will actually cover what we've talked about. So I'm not going to make you find slope and then later on we're going to find slope and then do something with it. So we're going to apply it all together. But this is the first part that's kind of a standalone individual thing. We're going to talk about horizontal and vertical intercepts. So I believe that's going to be the first 3 on the worksheet. So you might want to go ahead and print it out or pull it out if you don't have that already. So horizontal intercept, by definition, is the point where the graph touches or crosses the horizontal and typically x-axis. So I kind of did back and forth there because if we're talking about applications problems, we don't know it's necessarily x. So it is a horizontal intercept. But if it's a mathematical problem, it's the x-axis. Same thing with that vertical. Vertical is the y-intercept if we're doing just a strictly math problem, but if we're doing an application problem, it's the point where the graph touches or crosses the vertical axis. So example 7 has us just very basically talking about what that would look like on this graph. So in this graph, we have a line that's going through both axes, the vertical and horizontal axis. So by definition, the horizontal easily enough is that point in the bottom right where it's crossing the axis. So counting over 1, 2, 3, 4, 5, 6, 7, that point is 7, 0. And then same idea when we're doing the vertical intercept, that circle as a red circle on the top left of the graph, that is 1, 2, 3, 4, 5 up, so 0, 5. So that's the very basics of what a horizontal and vertical intercept is. So now let's look at what that actually is in a question, what we could see what that would look like, because that'd be a little bit silly to be on the test because you would just point and you'd be done. It is valuable to know what you're talking about, but there isn't a whole lot of math behind it. Where these questions, we can find our slope and our intercepts from an equation. So we have an equation right here, 6x plus 4y is equal to 12. Well, let's start by finding our intercepts. So the way to do it is, you may have noticed in the previous section that when you're finding the horizontal intercept, the y is always going to be 0. So to find that in this question, we say y is equal to 0, solve for x. So I plug in 0 for y, solve for x. Well, 6x equals 12, divide both sides by 6. I'll get x is equal to 2 eventually. There we go. Now, that's not the answer. That is what you did in algebra, and yes, you solve for x, but that's not a point. An intercept is a point. So in order for you to get full credit on this question when it shows up on the test, if it shows up on the test, is by writing it as a point, 2, 0, because we said y is equal to 0. So that's our horizontal intercept. Similarly, vertical intercept is, in this case, we're setting x equal to 0 and solving for y. So 6 times 0 is 0, that goes away, leaving me with 4y is equal to 12. Divide both sides by 4, I get y is equal to 3. Again, that's not a point. That is what y is, but that is not a point. A point would be 0, 3. That's my vertical intercept. Now, slope, well, we have 2 points there. My first point is 2, 0. My second point is 0, 3. So if I do rise over run, I would have 3 minus 0 over 0 minus 2. Again, that's that formula that we've seen before. I subtract the 2, I'm left with 3 is equal to negative 2.
Okay, so for the last bit of this section, we're going to take a look at some bar graphs, and we're going to use kind of a similar concept that we've seen before. We're going to use the information that we have from this to kind of build a model and then maybe use it to predict things. So here's my graph. It's about the sale of floppy disks. On my y-axis, you need to always title your y-axis and your x-axis and your graph itself. My y-axis has sales in thousands, and my x-axis is years, and then I have both years labeled. So the first question is, I want to develop a model for the trend of this graph. Well, what we're capable up to this point is developing linear models. So I'm going to try to find a line that goes through or follows a trend that this graph is kind of representing. So to do that, we need to kind of find points. And it doesn't look like we have points. It looks like we have 2 bars, but really those bars are just actually representing a point. So I'm going to pick 1990 as my initial year. That's when my model is going to start. And we can see that during that year I had 20 sales, so that point is 0.20. And then 1995 I had 35,000 sales, so I'm going to do 535. And so the 5 comes from the fact that it's 5 years after 1990, and the 35 comes from the fact that I sell 35,000 floppy disks. Now, it is worth mentioning that if you really want to, you could put your sales in the thousands. So instead of 0.20, you could do 0 to 20,000. It's not going to really affect your final outcome. Your model might look a little bit different from mine. Now that I have my 2 points, I'm going to find my slope. So rise over run, 35 minus 20 over 5 minus 0, I get 15 over 5, which is just 3. And I know, well, I already have one of my points is my y-intercept 0, 20. So I got that. So writing my equation y equals mx plus b form, my m is 3, my y-intercept is 20. There is my equation or my model. I kind of use those terms interchangeably, but that equation models what my graph does. So what we can do with this new equation is we can say, okay, let's assume that not a whole lot of things are changing. If my future can be predicted by the graph that I see here, what would I guess that the amount of sales would be in 2005? So, well, to do that, mathematically, I would plug in 15 for my x, because the 15 years after 1990 would be 2005. And I just do some simple math. I multiply 3 by 15, I get 45, plus 20 is 65. So I would predict in 2005 for there to be 65,000 disks. Now, if this was a question on the test, you'd done everything correct, you would get full points. But something to kind of think of when we're in the real world is it reasonable to assume that this is how the trend will go? Because if you have been around since 1990, you may know that, well, we don't really make floppy disks anymore, or if we do, we barely use them. So we have to consider that when we have 2 points, which is great, and we can develop a model, but we need to think, is this model a really good representation? Do we need to take other things into consideration that, especially with technology, sometimes things just kind of go out of style? So again, if you're asked this question on a test, all of this is perfectly fine. That is a math test world way to approach it. If you are in the real world, make sure you're thinking twice about these models that you have developed.